Shanti Prakash. I've already shared the so I've already shared the achievement badge. So you can this is the so and we wait for share the link chat box.
Hello, yes, your voice is too low, huh? In case if you are speaking, you need to fix your audio problem.
Audible now clearly?
No, it is quite low actually.
Is it better now?
Little bit better as you are speaking little loudly, but I doubt whether your audio problem is still fixed.
Okay, I'll check. Hello, sir. Am I audible now? Clearly?
No, Shubh. Actually, you are speaking loudly, so you are audible. But otherwise, I don't think your audio problem is still fixed.
Hello, sir. Am I audible now?
Yes, now it is better.
Okay, sir. So we'll start with the session. Hello and welcome everyone. I'm Shuk Parmar, your host for today's webinar. My team and I are here to make sure you have a seamless and engaging experience. If you have any questions or need assistance, feel free to use the chat window. We are here to help. So the topic for today is advanced analytics with Synapse, big data processing, and AI insights. So this webinar is hosted by the ATC community, a hub for enthusiasts passionate about cloud technologies, AI, machine learning, uh, IoT, open source development, and DevOps. So today's event is sponsored by Synergetics and Microsoft. Before we dive into today's session, let me take a moment to introduce Synergetics. Synergetics is a leading edge learning solutions provider in India, offering specialized training and consulting services. We empower businesses and professionals to thrive in today's fast evolving tech landscape by delivering transformative learning experiences. Our core focus is on enabling digital transformation through innovative skilling programs, advisory services, and end to end implementation support. From modernizing IT frameworks to mastering emerging technologies like AI, cloud computing, and DevOps, Synergetics is committed to equipping you with the tools and knowledge to succeed. Uh, These are all the 12 learning solutions which are offered by Synergetics, which are persona based onboarding add-on, certification add-on, reskilling, emerging technology training, certification hackathon, cloud adoption, latest technology training, sales, pre-sales training, practice playbook, and architecting. This is the Microsoft certification skilling journey. The journey begins with the fundamental certification, then progresses to advanced role based certifications, and finally to expert level certifications. We run communities on Meetup. This is the emerging technology community. Anyone who are eager to learn about technological knowledge can join this community on Meetup. We have multiple communities in Pune, Gujarat, Nagpur, and Indore. Those who are interested to join this community, please log into Meetup app and gain your knowledge for free. We are thrilled to have Mr. Chandrasekhar Deshpande as a today's speaker. He's a certified Microsoft trainer and a consultant at Synergetics. He brings a wealth of knowledge and experience in AI and cloud technologies. So, agenda for this webinar is this session covers Azure Synapse Analytics for big data processing, integrating SQL analytics, Apache Spark, and data pipelines. Topics include real-time data explorations, AI model integrations, and deriving insights from large data sets. We are providing a complimentary learning achievement badge for this webinar, which includes an overview of the module topics which are related to this webinar. You can share the badges on your LinkedIn and X profile as well. To get the badge activated, you just need to follow certain steps you can see on the screen and then redeem your badges. Also, the link is already shared in the chat box. Also, you have to follow the code of conduct, which will create a respectful environment for all the participants. Participants, please note you are not allowed to take screenshot of the presentation and cannot do screen recording. I would like to take a moment to share uh, some information about the workshops we conducted Synergetics. This webinars you have been attending are designed to give you a brief overview and summary of the full course content. However, the actual certification training programs for this course is run over 4 days, and we are currently offering them at a special discounted rate exclusively for webinar attendees. On my screen, you can see the list of in-demand certification courses we are currently focusing on. So for more details or to register, feel free to connect with Mr. Vivek Balasundaram. He will provide you with all the required information for this courses. So if you have any queries or you need to enroll for this courses, just connect with him. I've already shared his contact number and his email ID in the chat box. So everyone do follow us on our social media platforms to get relevant updates on upcoming webinars, workshops, and certifications, training. We conducted Synergetics. So and I've already shared the link to all our platforms in the chat box. So follow us, subscribe, and stay updated. Thank you so much everyone for listening to me. Now we'll hand over the mic to a speaker. So you can take over from here.
Thanks, Shubham. I welcome all of you for this short session of 2 hours on analytics in Azure. And there we will see what all we can do. Analytics in Azure Synapse Analytics. There we will see what we can make possible in Azure Synapse Analytics. So many of us perhaps are aware that Azure Synapse Analytics allows us to do data engineering, data science also, and it is a unified service, okay, where you can design data pipeline. It has Spark engine at its heart, and because of which everything that we can do on Spark engine, that API, that code, that program works here also. So we will try to understand the things one by one, and then we will touch to artificial intelligence also, AI services also. I am sharing my screen, and let us begin with the topic now. First of all, let me know whether my screen is reaching to all of you. Is it reaching?
Yes, sir, it's visible.
Thanks. So here we will try to understand some of the basics first. I will do a fast forward while doing a basics because we should get sufficient time to explore more on machine learning, predictive analysis, and generative AI or artificial intelligence supports available in Synapse Analytics. So first of all, let us understand that whenever we want to do any kind of data engineering or data science development, the very first thing is working on the data. Earlier, we used to have a data from the single source, but nowadays, what is happening that the things have become much complex, and we are supposed to ingest the data from more than one data sources. Every data source may have its own format of storing the data. So we have to deal with more than one data sources as well as different data formats. So today, just to understand quickly, structured, semi-structured, and unstructured, three types of data formats are available. And these three data formats make typical data storage also. For example, structured means relational database management system. In which data is always tabulated in always stored in tabular format in the form of the rows and columns. So that is structured, where predefined schema is imposed on the data, and data is bound to uh, uh, say formulate itself within the predefined schema. That is the structured data. Structured data down the line may be stored in proprietary format into the database. Oracle database may have its own proprietary format to store the data, like other databases may have their own format to store the data. So for structured data, in case if it is a data stored in Oracle, only Oracle can access it. If it is stored in MS SQL, only MS SQL can access it. So you need a specific kind of interface to uh, pull the data out of the storage or push the data into the storage. So data becomes bound to a specific tool. It is Oracle database or it is PostgreSQL database. In semi-structured, your data always mostly go into the text format. So JSON can be a text format, XML can be a text format. So that is the semi-structured where data still goes into the tabular format, okay, but it will always go into the text format, tabular text format. So JSON can be, somebody may say it is a tabular format, somebody may say it is a hierarchical format. JSON is not a hierarchical format, XML can be a hierarchical format, but ultimately data goes into the text format, which in order to explore the data, you don't need a specific kind of tool. You don't need a proprietary interface. Okay, so semi-structured data can be accessed using multiple ways. Unstructured means which doesn't have specific schema. So that is unstructured. It doesn't have a specific schema. So images, audios, they don't have specific schema. Their metadata may be stored in the form of a schema, but otherwise actual data does not go in specific format. That is unstructured. There are different operations to be carried out, like integration means connecting to the data source and extracting the data from there. That is integration. Now, this integration also has become challenging in the sense that we have multiple data sources from where we have to extract the data. So connecting to these data sources, bringing the data from there, data may be in the different and different formats. There may be variation in the schema. Like there may be same set of columns, but order of the columns in one storage may be different than the order of the columns in the another storage. So it's not the case that only pulling the data will work out. You will have to uh, get that data, convert that data, or transform that data into specific format. And for that purpose, you need a transformation. Again, there are n number of tools available which can do a transformation for us. And once we do the transformation, finally, we may have to do the consolidation. It means we may have to do aggregation of the data. Maybe for some of the groups, we have to calculate the average or some. So we may have to consolidate the data and aggregate the data. So different types of data operations we are supposed to do here. And again, here now, earlier there were only programming approach available, but as on today, with the success of no code or less code approach, many tools have been evolved which are able to do this data engineering without writing the code or writing minimal code. Okay, so these different data operations are possible through different tools also, which are UI based tools or which are programming language based tool, where programming language and libraries have been designed in such a way that with a minimum effort, a developer can do the development. Different languages. So SQL language, everybody knows, structured query language. We know by using Python also we can extract the data. So and we can apply transformation and a consolidation on the data. So whenever we say data engineering, a data engineer has to be aware of different types of data, different formats of data, ingestion process, transformation and consolidation process, and at least one language he should be aware of. At least one language, like as on today, if you see, Python language is considered to be one of the most popular language. Okay, and it is very easy also to work with and to learn with a very small learning curve. So many of the tools which are available today, in case if they are offering you development support, programming language development support, many of these tools definitely support Python. So I will say, as on today, in case if you learn Python, it is going to help you throughout the journey. Okay, it is a journey of artificial intelligence. Okay, so data engineering, and then in artificial intelligence, image processing. Again, there are Python APIs available, audio processing, Python APIs are available, text analysis, Python APIs are available. Another thing is, one more aspect I'm trying to bring to your notice is about the size of the data. Earlier, we used to have our data in one database, or we may be having a cluster of the databases, okay, to hold the data. But as on today, it has become a big data. The size of the data is extremely large. Data goes into petabytes also. Specifically, I am talking about the historical data. The companies who are they're working since 30 years, 40 years, or 50 years, they have accumulated very large data. And now, in case if they want to process it, definitely system should be capable of performing processing with a minimal time. And that's why complete big data processing system has been evolved. You might have heard the names like Hadoop, okay, for big data processing. And today we are realizing that Hadoop is, I mean to say, available in legacy systems only. In case if today you want to design a big data processing system from the scratch, definitely you will not prefer Hadoop, for the reason that it takes hours to complete the processing. So today you definitely prefer a Spark-like system where processing happens so fast, even if it is a big data, processing happens so fast, okay, that very critical, complex analytical operations also can be done within minutes or so. Different data engineering concepts, operational and analytical data. So OLTP, okay, transactional processing. Earlier we used to do transactional processing only. Not only. Earlier we used to do mostly transactional processing using databases. Databases are not supposed to do analytical processing. They are for databases are for transactional processing. But later, whenever we realized that databases are not good enough to do analytical processing, then uh, warehouses got evolved. Warehouses again represent data in the structure format, okay, but are able to do the processing, analytical processing faster than, too much fast than databases. So we got warehouses for analytical processing. Okay, but again, both these tools do support structured data only. What about um say semi-structured data, data in the form of JSON or similar kind of data formats? So there, then we have to have data lake. A data lake. Data lake can store any kind of data, if it is structured or if it is unstructured. Sorry, semi-structured and unstructured. And another thing about data lake is data lake offers you analytical processing on very, very large data. Means what they are saying, or the vendors who are offering you data lake services, they say that it can store infinite size of data. Although everybody knows practically it is not possible, but the crux of this sentence is that uh, extremely high quantity of the data can be managed by data lake. And data lake offers better IO speed also compared to any other storages. Okay, data lake can offer better IO speed for fast supplying the data with high speed, because down the line it is a distributed storage and it is massively scalable, and that's why they say that data lake can store data of infinite size. Another complication as on today you will see is about the streaming data. We have lots of streaming use cases where we have to pull the data from IoT devices, from video streams, from logs, from clicks on the web pages. So you are receiving this data, this is streaming data, which comes with a very high speed, as well as we have to have a real-time processing of such data. So quickly, the data should be analyzed and immediately the decision should be made. So Hadoop-like system definitely does not work here because Hadoop-like system takes hours to do the analysis. So here you have to have the system which can very quickly process the data, and there comes a role for the Spark to play. And here you will see Spark plays uh, processes data with a tremendous speed because Spark processes data in the RAM memory. Hadoop does not process data in RAM. I mean to say, Hadoop uses mostly disk storage. Okay, so Spark processes data within the RAM and stores the data within the RAM only. So disk interaction gets less in Spark, and that's why its processing speed is very high. This is all about data warehouse. So again, just to bring to your notice a brief difference in between operational storage, okay, database. Database is for OLTP like workload, and data warehouses are for OLAP like workload. Now here, as on today, ingesting the data from a number of data sources, applying different and different processings, transformations before that data is being made for report generation. Okay, many operations are to be carried out, and there you have to create something called as a data pipeline. In data pipeline, you will define the steps that from where the data will be brought, what type of operations which will be carried out on the data, what type of transformations which will be carried out on the data, and after that, the processed, transformed, clean, where the data has to go, what will be the destination for clean and processed data. So everything we have to define within something called as a data pipeline. You simply have to declare the data pipeline, and thereafter, whenever it triggers its execution, okay, it also automates itself for executing the steps which are to be carried out on the data. So orchestration of the data, okay, is possible in data pipeline. Extract, transform, and load like operations we can carry out there. So there are two types of operations here: ETL, extract, transform, and load, and ELT, extract, load, and transform operations. These two types of operations are there. We will see the difference between them also, in which scenario, which one to be used, and all nitty-gritties of selecting which to go with. Okay, that also we will see. I already told you about Apache Spark. Apache Spark is actually a processing engine, okay, which uses RAM memory at its utmost level, okay, and that's why increases processing speed tremendously. So it's an open source engine, and there are many tools, okay, having this Apache Spark engine at their heart. Many tools are there. Even many Azure services also offer you high speed processing using Apache Spark at its heart. If I have to map all these things with Azure services. Okay, Azure has SQL database, Azure SQL services. Okay, which offers you OLTP workload. For data warehousing, Azure has Azure Synapse. Okay, for stream processing, Spark Engine is possible. Besides that, Azure Stream service is possible. Streaming service is possible. Data Lake, all the cloud service and cloud vendors, okay, they do have a data lake like system. Azure has Azure Data Lake, AWS has S3 data lake. Yeah, and data pipeline. Data pipeline, we have a tool like mm, Azure Data Factory. Okay, by using Python also we can design a data pipeline. Now this Azure Data Factory, like things have been integrated with Synapse also, and many other uh, services of Azure have been integrated with Azure Data Factory data pipeline. So let us have a close look to this diagram to understand data processing in further details. Operational data we normally receive. This is transactional data that we receive from multiple data sources. Okay, so we ingest the data with either ETL or ELT. Okay, and now here you will see two pipelines. This is one pipeline and this is another pipeline. Let us talk about first pipeline only, in which huge data has to come in. Okay, has to be applied with a different and different transformational steps. Okay, and finally that data is to be used for report generation. And here you will see basically this pipeline represents uh, batch processing, where huge data running in petabytes maybe, okay, comes in, okay, transformed, cleaned and transformed and then processed and is made ready for further uh, processing like report generation and like machine learning. Okay, so here huge data comes, and then Azure Synapse Analytics can be used here for this purpose. Azure Synapse Analytics processes that data, okay, makes that data ready for further consumption, and thereafter, then in data modeling and visualization, that data can be consumed. Here it can be Power BI like tool, it can be your application, okay, your another custom application also can consume that data. Another pipeline represents a streaming. Here it is representing IoT device. So IoT device may be sending the signals after specific interval. Okay, and there is something called as a Azure Stream Analysis. Azure Stream Analysis is a Azure service available, okay, which can pull the data from streaming data from IoT devices and other streaming resources. Okay, and once that data comes, that data can be pushed to Synapse Analytics or tools like Synapse Analytics. Even you can think of, somebody did ask me about a Fabric. Okay, that data may go into the Fabric also. Microsoft Fabric I am talking about. Okay, and processing can be done there, and thereafter, your data may go for report generation. Like Azure Synapse Analytics, we have another platform also called as Azure Databricks. Actually, it is Databricks platform introduced by Databricks Incorporation, but it has become a first class. It has been offered as a first class citizen in Azure. Okay, and so Azure Databricks also is some way can be used to process your data. If you want to compare Azure Synapse Analytics and Azure Databricks, I will definitely say Azure Databricks, okay, is more popular for the reason that Azure Databricks is in market since long. Actually, there are three technologies here: Synapse Analytics, Fabric, and Azure Databricks, which are competing with each other. Okay, and you have to do the comparison to know which one to be used in which scenario. Okay, but here briefly, what I can tell you is Azure Databricks is very versatile. Okay, it offers you many types of processing, and many organizations look at Azure Databricks to be one-stop solution to get all types of data processing at one place. So in Azure Databricks also, you can do data engineering, you can do data science, you can do generative AI development also. Okay, Synapse Analytics, as on today, does not support generative AI. It does support artificial intelligence services to be pulled in, but it is yet to support full-fledged support for generative AI. Okay, these are just few questions. Okay, you can unmute your mic and answer these questions. Data in relational database is. Please quickly answer. Please quickly answer. Data in relational database is. Let me check. Are you putting the question and answers in the chat? Okay. Yes. Yes. Anyway, now answers are visible here. In a data lake, data is stored in terms of files. It is also called as a object storage. In Azure, we have Azure storage account where your data goes in the form of the files. Yes. Which of the following Azure service provides capability for running data pipelines and managing analytical data in a data lake or relational data warehouse? Remember here, this Synapse Analytics, what all it can offer is, it offers a big data processing, it offers data warehousing, it can be used to design data pipeline. Okay, you can design a data pipeline. You can do as it offers you Spark engine. Okay, and it has a special library called as the Synapse ML. Okay, it offers you data science also. So all these things at one place. You don't have to use the different tools for different purposes. Okay, in Synapse Analytics itself, you will get all these things. So here answer is Synapse Analytics. Why it is not going next page? Huh. Okay. Huh. Synapse Analytics. Okay, this will be your Synapse Analytics portal. This is a view of Synapse Analytics portal. I will take you to the Synapse Analytics portal also. Large scale data warehousing. Here it can do large scale data warehousing. Advanced batch and real time analytics, both are possible. This is something interesting. Okay, batch and real time analytics, both are possible here. Data exploration and discovery. It allows you to version the data, explore the data, and discover the data. Okay, data integration including HTAP, hybrid transactional and analytical processing. So HTAP is also possible. Now, what do you mean by HTAP? That whenever you are getting the data from row major storages. Now, let me quickly explain you. Okay, I think I will have to. Uh, Row major storages. Your databases are row major storages. Entity wise, records are stored, and such a data, okay, takes a longer time for analytical processing, because for analytical processing, row wise data does not suit, but it needs column wise data. Column wise data. So whenever you are pulling the data from row major storages like database, okay, it takes a longer time for analytical processing. So there then HTAP system convert that data from row major to column major on separate compute. So your analytical processing compute, is not used, and analytical processing compute can fully focus on uh, analytical processing. It can fully focus on analytical processing. So that also it supports, it will have a separate compute which will convert or transform row major data into column major, and thereby that column major data can be immediately consumed without any transformation within analytical processing engine. Okay, and that definitely increases performance of analytical processing engine. So that is called as a HTAP. Integrated analytics, fusing data inside solutions into everyday workflows and applications. Whenever you are using any application and you want in that application you want to pull the data from the Synapse Analytics. Okay, so immediately you can pull the data from Synapse Analytics into your application. So Synapse Analytics becomes queryable. Okay, and whenever in your application you run the query to pull the data from Synapse Analytics, it is possible. So it has integrated analytics solution also. Okay, so uh, linked services. Now let us go into further details of Synapse Analytics. But yeah, I will quickly read this couple of slides and then I will take you to the demo. Okay, there is something called as a linked service in this Synapse Analytics. Similar kind of linked service you might have seen in Azure Data Factory also. Exactly same linked service is available here. This link service basically holds all necessary meta information to connect to the data source. So in case if you have one blob storage or a data lake store where your data is already existing and you want to get that data into Synapse Analytics, okay, you have to first of all create a link object, link service object. That link service object creates, holds the metadata to connect to all credentials and metadata to connect to the data storage. Okay, it also hold the metadata of the schema of the data. Okay, and thereby using link service. So link service works as a bridge in between Synapse Analytics compute engine and actual storage. So this link service brings the data from there. So we have to create a link service object here, and thereafter we will get the data. Now they have introduced a new concept called as a lake database concept. In lake database concept, okay, we can apply our relational concept for a semi-structured data. Relational concept for semi-structured data. Your data may be in the form of the CSV file, or it may be in the form of JSON. Okay, so what it will do in this lake database concept, that it will read the data from CSV format or JSON format and will present the data in the tabular form to you, to your application. You can just see that data in the tabular form. Okay, and not only you can see it in the tabular form, you can create a relations among different uh, tables. So you can do design joins there. Okay, different types of joins also can be created. So, one to many, one to one, many to one, and even many to many also. Different kinds of joins can be created here. And even if that data is not from database, not from data warehouse, okay, it is in the form of the text, still you can see that data in the tabular form and you can see uh, relations among that data. So that is something lake database concept offers to you. So irrespective of the data format, okay, lake database offers you relational database data management system. So Parquet files can be there, CSV files can be there, okay, and thereby it can refer to that data. You can create a relations among the data. In order to do the processing, here we have Apache Spark pool, here we have serverless SQL pool, ex- three types of computes are available here: serverless, Apache Spark, and dedicated. Three types of computes are available. Here we can design a pipeline also. Okay, the way we design a pipeline, data pipeline using UI in Azure Data Factory. Okay, and we can apply different and different transformations on that pipeline. So data flows also can be designed. So Synapse Analytics support designing data pipeline and designing data flows also. Without writing a code, you can do the transformation. Yes. Let me just check. Have I received any message? Just a minute, because I saw a message there. Ah, okay, I have got one question. Synapse Analyst, it tells that it helps for large data analytics. So then, is this all possible with no code, low code approach, or we can use a Python or Spark in this, like how it helps to perform data analytics? Really nice question. And the answer to this is yes, Synapse Analytics offers you large data analytics processing. Okay. And you can make it possible with no code, low code approach. You also can make it possible using Spark. Both way you can make it possible. Spark allows its own library API. Also, Spark allows Python. So Spark allows you Python also. So both way it is possible. Now here I would like to mention one thing that in Azure data factory, there also you can do designing data pipeline using low code and no code approach. Similar kind of data pipeline designing is possible here. Okay, but yes, it does have limitations of some typical critical customization. And whenever you want to do that customization, then you have to write, you can do the similar things using Python code or Spark code. So, yes, through Python code also it is possible. But in case if it is a simple case, okay, you can make it possible using designing data pipeline using graphical user interface. In order to run SQL, we have serverless SQL pool here. We have dedicated SQL pool also. Okay, both way it is possible. Dedicated SQL pool basically defines data warehouse. Yeah, and there we have Spark engine also. They are offering you Jupyter notebook like editor. Now they are calling it as a Monaco editor. Okay, but it is much similar to Jupyter notebook like editor where you can do Python development. Okay, so Spark engine, there is very nice thing about this Spark engine. I already told you that Spark engine can process a big data with a tremendous speed. That is fine. Another important thing is in Spark engine, multiple languages are supported. So you can do Python development, you can do R development, you can do C# development. It allows you executing SQL queries. So even if you are from different backgrounds, you can do the development using Spark engine. It is open source, highly scalable, distributed processing engine, and it does have common libraries also, multi-programming languages also. When you are designing or developing one program, and in that program, some part you want Python developer to write, and some part you want to use from the R library, in a single program, you can have different statements written in different languages. That is what Python allows you. For some kind of processing, if you feel like R libraries are better compared to Python libraries, in the same program, that transformation you can get done by using R library. That is something very nice in Spark. SQL pools in Azure Synapse Analytics, serverless SQL pool, and dedicated SQL pool. Serverless SQL pool, whenever you execute the query, that serverless SQL pool, uh, say, take that query for execution, executes the query. Okay, whenever it takes that query for execution, it starts billing you. And when it completes execution of that query, it stops billing you. So it is on demand query processing. Here, this serverless SQL pool, they are live servers. You don't have to configure them. They are servers, okay, which does not need configuration, and they are up and running all the time. Whenever you run the query, that server simply is brought out of the pool, okay, it executes the query, and that server goes back into the pool. But as you don't have to configure it, that's why they are calling it as a serverless, because you don't have to feel a heat of configuring the servers, configuring the servers and starting the server and shutting down the server. You don't have to feel the heat of. These servers are 24 by 7 up and running. Whenever you submit a query, server comes out of the pool, that query is executed there. Whenever it takes the query, it starts billing you, and you will be kept billing. Okay, pay as you go. Okay, whenever it runs the query, it stops billing and it goes back into the pool. That is serverless SQL pool. Okay, dedicated SQL pool, on the other hand, they are to be configured. They are alive until you explicitly shut them down. Or if timeout happens, then also they are shut down. But somehow, human intervention or auto shutdown like intervention is needed to shut them down. But they are dedicated resources for you. You can make them scalable, but otherwise, whatever be its minimum size, that minimum size will be live for all the time until you shut it down. So dedicated SQL pool also is there uh, in Synapse Analytics. Okay, let me take you to the demo now, and in this demo, I will quickly show you how can we work with a Synapse Analytics. So just a minute. This is my Synapse Analytics. I will have to search for it. Just a minute. Yeah. So just a minute. I already have opened. Let me take you to that resource group where I have created these resources. I already have created these resources for you so that we should not waste our time in creating the resources. 50, 03. Here. So here you can see Synapse Analytics resource I already have created. Okay. And that workspace I have already opened here. Uh, that workspace I already have opened here. So here is that workspace I already have opened. So like other services, I did create the Synapse Analytics here, and here it has its own portal. So as of now, I am in the portal. Okay, I am in the portal. In the left side margin, you will see here all data assets can be mentioned, can be maintained. Different data assets can be maintained. So connection to the data lake store, connection to the database, okay, or connection to the other data warehouse, that is also possible. Okay, and here whenever we create a databases, those databases are also visible. Just a minute, huh? I think this is not I am looking for. Here it is. Okay, same. Huh. Yes. So all data assets are maintained here. Here is the development environment. different types of notebooks and SQL scripts can be created from here. So this is the developer's workspace. Whenever you want to design data pipeline, then from here you can create a data pipeline the way you might have created in data factory. In the similar way, from here you can create a data pipeline. Different resources if you want to monitor, different processings if you want to monitor, from here you can do that. Okay, so pipeline runs and other things you can monitor from here. SQL request and KQL request you can monitor from here. And whenever you want to create some assets, okay, like SQL pool, okay, Spark pool, from here, from the manage section, you can create it. Now here, if you see, whenever I created this workspace, okay, one dedicated, serverless SQL pool has already been created. But as of now, no resources have been allotted. I told you that resources are pulled out of the pool whenever it has to execute your query. So as of now, it is not billing you. So creating a serverless SQL pool does not start billing you. It will start billing you only when it has to run the query or it has to run any job, whatever you have submitted. For the period it has to execute that job or query, it will bill you. So for serverless SQL pool, what is the best thing is that serverless SQL pool is available 24/7. And Acha, I have got one more question. I already know Python and I have no idea about Spark, so wanted to know the syntaxes and code of Spark. Is it very different than Python? A person can easily transition from Python to Spark, yes or no? So, Shubham, see, Spark libraries have been designed in multiple languages. Okay, so there is a Python library available. We call it the PySpark library. PySpark library. It uses all syntax and semantics of Python itself. It's only separate library defined, but otherwise it gets executed into Python virtual machine only. So while working with a Spark, nowhere you will feel like you are working with any other language than Python. Okay, it's a Python only. Okay, so in case if you have learned a Python, you simply have to learn the different APIs available in PySpark. So that is not much difficult. So that API can easily be understood. A person can easily transition from Python to Spark. Yes, very easily. In case if you are good in Python, working with the Spark is very simple. Okay, concepts only you should know, but otherwise it's like working with a Python only. Huh. Okay, so this is manage section, and here is I already told you about the data section. Now what I do, I go to, just a minute. Yeah, I will share this link with you. Okay, you also can refer to these steps. I will do the demo for you using those steps only. So here is a link. Okay, so first step is asking me to log into the portal. I already did that. Second step is asking me to go to PowerShell. Now, why to go to the PowerShell? If you scroll down, okay, here you will see execution of one PowerShell script. What this PowerShell script does is it uses CLI commands to create Synapse workspace. It uses CLI command to create Synapse workspace. That step I already have done for you, and Synapse workspace is ready. Okay, so I don't have to follow these initial steps. Okay, I directly jump to, just a minute. Where is the data? Some data files to your data lake. Okay. Here, the first step what it is asking you to do is to, just a minute, huh? I think wrong URL I am referring to. Just a minute. Okay, fine. No issue. We will go with that URL. Okay, so here, see, whenever I run this setup.ps1, what it also did, that also let me show to you. Um okay, if I go to the data section, here it has uploaded the data. That CLI command has uploaded the data also. So let me show you that data. Yes, 2019.csv, 2020.csv, and 2021.csv. Three files it has uploaded. These are three data files. Okay, what next thing I will have to do is to uh, start the Spark engine, because now I am going to write some Spark script, okay, to ingest the data from these files, apply some transformation over there. Okay, and for that purpose, then what I will have to do is to create a Spark engine. I don't get a Spark engine ready when I create a workspace. So SQL pool has serverless engine which does not have resource as of now. And this is a Spark engine. It is a separate engine. Okay, so let me first of all configure the Spark engine and let us create this Spark engine. Okay, so Spark pool name may be DP 203 Spark pool. Okay, now Spark needs a high quantum of RAM, because I already told you that Spark has to do a big data processing, holding the data within the RAM. So Spark gives you utmost performance if you have machines with a higher size RAMs. So that's those machines are being called as a memory optimized, and there are drivers also, to manage the RAMs, because of which performance of Spark goes leaps and bounds. Okay, node size. Let me. Acha, only letters and numbers. Hyphen is not allowed here. Okay, fine. Let me go with a smaller size uh, server, okay, to cut the cost. Okay, I do not want to auto scale. Let me make it non-auto scalable, but with this option, you can make it scalable also. Number of nodes. Okay, let me go with the minimum number of nodes, because I do not have very large data. Okay, so thereby I am taking simply a couple of measures to cut the cost. Okay, estimated price is also being shown. Dynamically allocate executors disabled. Okay, another thing is about additional settings. So here I am configuring Spark engine. Okay, now here, here I am defining, in case if that Spark engine remains idle, okay, for 15 minutes, it will automatically start shutting down. Let me increase this time to maybe 30 minutes. Okay, so that in our session, whenever I am explaining, it should not shut down the engine. Okay, here are the versions of Spark available. Python version, what it use, Scala. This complete Spark has been built using Scala language. Okay, it uses Scala language, and this Scala language uses JVM, Java Virtual Machine, and that's why internally Scala uses Java Virtual Machine. That's why Java JVM version also is appearing. Okay, this workspace. Okay, fine. So I think there is no other setting. Let me go with review plus create, and then it will start provisioning Spark engine. Okay, so it will take some time, maybe 2-3 minutes. to provision the Spark engine. And from here I can see its progress. So it is still deploying. Remember, here I have configured Spark engine. Okay, what versions I have to take there, what is the size of the cluster, everything I have configured there. So this is a kind of a dedicated engine. That point also to be noted. This is a kind of a dedicated engine. This is not serverless. So Spark engine is created. Okay, my next step of lab is asking me, hmm, okay, orders, here in data, inside of files. Okay, these files are existing. Fine. Okay, now let us explore the data. Here is a code. So I have to create, let me do one thing. What I do now, on one of the CSV file, I right click there, just a minute, and I ask it to write a notebook for me, or to load the data file. Okay, so here, this particular platform writes some code for me. Okay, I don't have to write every part of the code. Some of the code it writes for me. So here I am asking it to create a notebook. Let me collapse this blade so that I will get a wider screen. Here it is. Okay, and here I am asking it to go to the storage. I mean to say it's a data asset. Okay, and read the data from there. Sales orders, files, sales orders. Yes. So this CSV file I am asking it to read. Format is also being mentioned there. Okay, and whenever, so just few more points to bring to your notice. This particular thing is asking it that it is a PySpark code. In this cell, it is a PySpark code. Cell is a batch of the code, batch of the statements, Python language statement. Okay, and in this cell, all are PySpark code. That is what I am first of all asking it to understand. So engine, when received this command, this is called as a magic command. Engine comes to know that the following code is Python, PySpark code. As I already told you, that every cell can have its own language code. So another cell may have SQL, the third cell may have C sharp, fourth cell may have R language code. So how does it come to know which language code? Okay, we are intending to submit to it. So that happens through the magic uh, command. Okay, so spark.read.load. I will not go into too much depth of what this Spark is. Okay, I simply can tell you that this is the command to connect to the data source and bring the data of the format mentioned here. Okay, so here it will create something called as a data frame. Data frame is something which represents the data in the RAM, in the RAM memory. Okay, and then I am asking it to show me 10 records. So let me put it to run. Okay, but before I put it to run, I have to attach this notebook, okay, to the Spark pool that we just have created. So I'm attaching it to the Spark pool. I have attached it to the Spark pool, and now I'm putting that code to run. Now here, see, what it has to do is to make the environment ready. It has to make the environment ready. Okay, in that environment, it has to create a Spark environment, then it has to create something called as a Spark context, something called as a Spark station. Couple of things it has to do. So it is in order to run the first command, it will take a longer time. But once it makes the environment ready, thereafter it doesn't take that much time. Your subsequent commands are executed really fast. So let me wait for a while here. Shubha has shared a feedback also, so everybody is requested to fill the feedback before you leave from the session. Now here we will have to wait for a minute, okay, for it to create the environment and run this command. The command in the second line is actually to connect to the data source and read the data from there, bring the data into the RAM, and into the left side we call it the data frame. That data frame represents the data which is in the RAM. Command 6, command third and fourth, they are commented. Okay, hash is a comment in Python. Command 6, ask it to show me initial 10 records. Okay, I will just come to know whether command in the line 2 has been executed successfully or not. Shubham has asked me, PySpark better than Hadoop? I will say yes on all fronts. PySpark is better than Hadoop. But what one more point I would like to mention here, PySpark runs at the top of Hadoop environment only. So it uses distributed processing of Hadoop environment. Okay, but in processing, okay, with respect to speed, with respect to features, it is far better than Hadoop. It can do batch processing. Hadoop can do batch processing only, but Spark can do batch processing and stream processing also. And thereby it can, provide you solution on many use cases where batch and stream processing has to go hand in hand. Okay, has to be done together. There are many such use cases, okay, for which batch and stream processing have to go together. And there, Spark provides you end-to-end complete solution. There is one more API available in Spark for your information. We call it the Delta Lake. Delta Lake API. Delta Lake API offers batch processing and stream processing to go hand in hand. Hmm. So environment is ready. Now it is executing the command. So in order to execute the command, all necessary components now it is accumulating. So remember, Spark normally does not take this much time in running the commands. Here it is taking the time because it has to, do lots of homework. If you try to run this command in Databricks, it gets immediately executed because in Databricks, your cluster is comes with a ready environment. Here it has to create the environment while running the very first command. And here is the data. This data does not have column names. That's why it realized that it does not have column names, so it has given the names here. C0, C1, C2, something like that. But here you have got the data. Yes. Okay. Now this data does not have schema because from the CS, acha, one more thing would like to tell you. Okay, how much data it has got from this file? Let me show you. Okay, in order to add another cell, here is a button available. Okay, how much data we have got? So df dot count, it will show me the count of the data. So it has got 1210 number of records from this file. Now what I do, same code I run for all the three files. All the three files, 2019, 2020 and 2021. So for that purpose, what I have to ask it to do is to go to orders folder and pull the data from there. Okay, so whenever I mention asterisk, it means inside that folder, it has to go into all the CSV files and bring whole data. Now see, this is a distributed system. And in distributed system, you hardly will get data into single file because your data gets processed into multiple nodes in the cluster. Multiple files are created. So this is a way to bring the data in case if data is spreaded across multiple files. Okay, now let me see. Let me put it to run and let us see how many records now it brings out of all those three files. Okay, how many records have it brought? Let us check. So df dot count. Now there are 32,718 number of records in all the three files. So here we have got this data frame, single data frame. Okay, this single data frame has got now 32,000 rows. 32,000 rows, and this data frame has accumulated all these rows into RAM. That is something very interesting to understand. Okay, now on this data, I want to apply schema. So here is a code in PySpark to apply the schema. Here I am declaring the schema. In the schema, I am declaring the column names and I am declaring column type for every column. So column name and column type, what I am declaring. And again, same data now I am pulling out. Same data I am pulling out. Okay, but here I am imposing this schema on that data. So the first column will not be named as a C1. Now it will be named as sales order number. Second column will be named as sales order line number this way. Let me put this code to run. And now it will apply, impose a schema on the data and now see how it will show you the data. It is taking longer time. Okay, wait for a while. So code is same. The only thing is here I am imposing the schema and how I am declaring the schema. Just observe here we am declaring a field name and field type. So string type, integer type, date type, float type. All these are the types we have say coming from this PySpark library. Sorry, this PySpark library. From here, structure type, structure field, and string type, integer type, like classes are being imported, and those are being used here. It has taken so long time. It is taking so long time. So here it is showing me how much time it has taken, or it is taking to run the given command. Here it is showing me that still the execution of this command is going on. Okay, here also it is showing me status of the server. That server is busy in running these commands. I think I made one mistake. Sorry. Okay, this thing I would have copied here. That mistake I did. So let me cancel this command and let me mention that here. So storage name is not properly mentioned. Okay, and that's why perhaps it went into creating the error, and that's why it was taking a longer time. Okay, now let me put it to run. Immediately you got the data. So earlier actually it was searching for the data source, but now it has got the data immediately, and see column names are also appearing there. Column names are appearing. Column types have also been defined here. If you want to see the schema again, okay, so all the data, okay, 100 records it is showing. If you want to see the schema of the data, okay, that is also possible. Print schema. And here is a schema, and there you can see you can impose even constraint over there. So whenever you declare the schema, you can define the constraints also over there. So now it has become a structured data. It might have pulled the data from CSV file, but now when that data has been brought into RAM, now it has become a structured data. And on this data, then we can apply different analytical processing. So here is a Spark command. Uh, So from the data frame where actually data is existing, I want to pull only two columns. How many rows are there in this? Now this is another data frame of which the name is not DF, but its name is customers. How many records are there? How many unique records are there? Okay, distinct records are there. Okay, and display unique records. That's what I want it to show to me. Okay, so unique records means customer name as per the customer name. So let me put it to run. Okay, so API again is a pure Python using Spark library. So say DF, this is a Spark syntax. Okay, this is a count method available, distinct method available in Spark library. So though there are 32,000 records, unique records are 12,000 only. So these many customers are there. Okay, so this is showing me a list of the customers. So see that API is really simple. And one more interesting thing, that Spark engine is at the heart of the Synapse. Spark engine is at the heart of the Databricks. You can have your own Spark cluster, on-premise Spark cluster. Okay, whatever code here you are writing, okay, it is a Spark code which works in all these tools. Here now we are making it to work in Azure Synapse. Okay, same code can work in Databricks. Same code can work on your on-premise Spark cluster. Here is what you have got the list. Okay, so API is very simple. API is a self-explanatory. Okay, and interestingly, once you learn this API for one tool, okay, you can use it into other tools also. Okay, complete list of 12,000 it is showing me. Let me do one thing. Let me clear this output. Okay, otherwise it's a very long output. Let me clear this output. Clear output. Yes. Next code. Okay, I can apply where clause also, and I can filter out some of the results there. So here you can see I can apply where clause, uh, and it is like a where clause, select and where clause, select like method is there. Okay, where like method is there, group by method is there, distinct like method we already have seen here, which are resembling with reservables available in SQL. Okay, and hereby you are becoming, you can see it as more familiar in case if you are coming from SQL background. So here I am asking it to filter the records or and pull only those records which are of this item. Okay, then number of records, distinct, and everything that you can see here. So there are 133 records. Okay, of this particular item, root 250 red. Okay, there are 133 records. So you can apply where like clause also you to filter in the records. Aggregation also is possible. So group by like method is available. So remember, concept is same, meaning of the group by clause in SQL and meaning of the group by method here, same. Okay, so uh, uh, very easy to work with it. Okay, let me clear this output also. So this way you can do different and different types of analytics in the Spark. Okay, you can do group by summarization, average calculation. Okay, that also you can do here. Okay, so here you can see we have got the data. Okay, now one more thing I would like to show to you is in case if you want to see some visualization, that is also possible. Okay, so I can define a chart here and see bar chart also it is defining. If you want to customize this chart from here, you can do that customization also. From here, if you want to, you know, uh, change the values. Okay, now it is as of now it is a item against a sum of quantities. Okay, so that is also possible. You can change the values from here. Okay, if you want to use, can I have a vertical chart, column chart here, column chart, apply, see column chart. So you don't have to, entangle yourself by using for writing the code for matplotlib or Seaborn. Okay, libraries. You can use the charts also. Although matplotlib API and Seaborn API, those are also available here. Okay, yes. So those can also be used here because after all it's a Python only. See here another code. Okay, order by clause also can be used. Order by clause also can be used. So this API is really rich. Okay, everything what you can do in SQL, you can do it here also. So here you can see year-wise order date. Okay, group by year, count order by year, year cells. Okay, it is calculating year-wise cells. Okay, so uh, here also, in case if you want to design a chart, that is also possible, and you can configure it. Okay, bar chart. Uh, Here, let me mention uncheck count and let me mention year. Okay, that is one thing. And values will be okay count. Yes. And with that, if I apply, okay, this is the graph. You can configure it also. You can query this data using Spark SQL also. So here you can see, okay, you can use Spark SQL. So in case if you are from the database background, that is also possible. Yes. So here I am asking it to create in memory table. They are calling it as a temp view. Okay, so actually it's a alias what we are defining over the data frame to the data frame, and we are creating a kind of a tabular wrapper around the data frame so that now we can query that data frame using SQL syntax. So here you can see it will show you the data. So select queries also can be executed there. So multiple such things we can do there. See SQL. Okay, now here you executed it using Python. You run SQL using Python syntax. But if you want to run it using SQL syntax, this is the way. See there, what change I will do is, let me clear the output. Clear the output. Let me write a new code. Okay, I simply mention a magic prompt here, for which I will just intimate to a Spark engine that the code written hereafter is a SQL code. And same Spark engine will run this code now, considering this to be SQL code. from sales order. From sales order. What is this sales order? So it is a temporary view what we have created. So from the sales order, group by year, group by so order by order year, and what I am asking it to do for me is to calculate sum of total sell gross revenue, okay, year wise, and here is year wise gross revenue what it is creating. So SQL syntaxes are also allowed. Different way to visualize the data. I did show you this way to visualize the data. Okay. How do we visualize data using matplotlib? Now here you see the visualization what they are offering here through the chart. It has limitations. Okay, it cannot create a visualization. Um, uh, it may not meet your expectations, all possible expectations. Okay, so in order to have custom visualization, you can have matplotlib. Copying it. Yes, matplotlib. No, this is the query only I am running. Okay, and then we will see how can we uh, uh, draw the visualization using matplotlib. So here is a code for writing matplotlib. Again, matplotlib is a library available in a, Python. Okay, so that library we may use here. So everything that works in Python works here also. Okay, so here is a matplotlib we are importing. Now matplotlib takes not a Spark data frame, it takes a pandas data frame. Okay, so Spark data frame is to be converted to pandas data frame. Now here you also note one very important thing, that these data frames are two-dimensional structures. But how are they different than two-dimensional array? Why are we calling them as a data frame? Why don't we call them as a two-dimensional array? There is a very basic difference between them. Arrays represent row measure structures. Data frame represents column measure structures. And that's why data frames are highly performing for analytics. Arrays do not perform well for analytics because they are row measure structures. So wherever there is a data frame where it represents a data in a column measure format, we call it as a data frame. So in Pandas also they are offering you data frame. So Pandas is a library of the Python, but we call it as a Python data frame or Pandas data frame. In Spark, a similar kind of column measure two-dimensional structure, we call it the Spark data frame. In R language also there is a data frame. So wherever there is a column measure two-dimensional structure, that structure is also always called as a data frame. Okay, so Python data frame or Pandas data frame, sorry, Spark data frame is to be converted to Python data frame, and then it is to be used here. We are using that data frame to submit the data to the matplotlib bar chart. Okay, so order year along x-axis and gross revenue along y-axis. So let us see that. Being a part of the analytics, visualization has to be understood. Okay, and that's why matplotlib is also being covered here. Okay, again modified visualization by matplotlib, where along the x-axis it will label, along y-axis it will label, to the whole visualization it will give the name. Okay, so I will not go into the nitty-gritties of how can we asking it defining X label, Y label, grade. Okay, we will not go into those details. But the point what I want to bring to your notice is every kind of customization is possible here. Revenue by year is a title for this visualization. Revenue along Y-axis, revenue year along X-axis. Okay, yes. Further modified structure. Okay, and I think here it has two visualizations in one slide. Two visualizations. See here. So bar chart and pie chart, I think both are no. Some changes may be there in grid, in grid perhaps. Some changes are there. Okay. Let me take you to the two visualizations. Pie chart and bar chart. Yes, this is the code which shows two visualizations in single tile. Yes, yes. Here is matplotlib. Okay, in the same line, here you will see Seaborn library, okay, and other libraries available. Okay, so multiple such libraries you can see here. So this is the way you can do the analytics there. Also, it allows me to do machine learning, okay, which is again a part of the advanced analytics. For that purpose, as of now, I have brought a code for you. This code runs. Okay. The only thing is, I will have to upload this data to the Synapse Analytics, but this code basically is for Synapse Analytics only. Now, in this code, you can see, okay, this is using MLlib, Spark MLlib. It is using Spark MLlib. So here is a Spark code to bring the data. Okay, here it is bringing the data, reading the data from the data source. Then here it is exploring data analysis. So we may be drawing some, say, visual to get the insight of the data. So we may have to identify are there null values, whether data needs some kind of cleaning. Okay, for that purpose, we may have to draw some visuals to know the profile of the data. Some box plot we may have to draw to identify outliers. Okay, so in case if you are already in data preparation activity, you know what I am talking about. You know, so box plot can be used to identify outliers. We may have to remove those outliers also. So there may be a number of ways of cleaning the data, and for that purpose, you may have to, draw some visuals. Okay, so those steps are being shown here. So here we will be drawing some visuals. Okay, we may be applying some featureization also. So we may have to, say, uh, say filter out some data here. Okay, pick up the data of specific type. We may have to do encoding. Encoding means whenever there are string values into the data, those string values are to be converted into numeric. Why they are to be converted into numeric? Because Spark or even machine learning algorithms work very fast on numeric values compared to string values. So whenever you convert your string data also into numeric form, then machine learning algorithms work very fast. I mean to say, not very fast actually. What I mean to say is they offer you better performance, better accuracy. That's why encoding is necessary. So here we are using one hot encoding, which will convert string values into numeric values. Okay. And then as usual, whenever we talk about a machine learning, okay, we have to, split our data into two parts. Okay. One is for training purpose. Out of complete data, 70% data we will use for training purpose, and remaining 30% obviously will go for testing purpose. So here we are doing random splitting, training fraction and testing fraction. Okay, so remaining 30% will become testing fraction here, and we will get the training data into this data frame and testing data into this data frame. And then here is a code which will Apply logistic regression. Logistic regression is one of the say algorithm of classification type. Okay, so here I am assuming that all of you are aware of machine learning basics. Okay, so that's why I will not go into details of machine learning. Okay, but here you will go with a logistic regression. Okay, and then here you will apply, you are creating a pipeline. Okay, pipeline of class formula, logistic regression, and either you will fit the data there, and here you will get the predictions from the data. Here you are drawing some matrices to know the accuracy of the model. Okay, and then here we may be visualizing the performance of the model using some plot. Okay, here we will visualize is using the plot. The point what I want to bring to your notice is this code, okay, we can run in Synapse Analytics. Okay, so this code actually, from where I have got this code, let me tell you. Okay, I have to go to the home. Just a minute. Huh? Where I have to go, discover more. Knowledge Center. I have to go to the Knowledge Center. Okay, and in Knowledge Center, here you will get different samples available, different galleries of sample code and open data sets. Okay, so from many domains they have ready data and code available. So from here also you can this also you can refer for more and more study of advanced analytics. So from here I have got that code, but that code also I can put to run in my application in advanced analytics. Okay, one more thing, last thing I would like to bring to your notice is I will share this URL with you. Uh, Let me share this URL with you. That URL talks about how can you utilize Synapse Analytics. Sorry, how can you utilize artificial intelligence services in Synapse Analytics? Let me share that URL with you. Okay, and there at that URL, what it is asking you to do is here you will create a Spark table to pull the data from. Okay, and then you will use Azure AI Service Wizard. Now, what is this Azure AI Service Wizard? Okay, let me tell you. I have just 10 minutes remaining, so I will have to complete it within the 10 minutes. Why it is not? Yes. Okay, we understood all these things. I will bypass these things. This is regarding the Spark. I already took you to the code. Okay, from the code, we understood many things about the Spark. Huh. Yes. Huh. Azure AI services. Now in Azure, we have set of cognitive services. Okay, there are many cognitive services available, and all these services are accessible within Synapse. Okay, so generative AI services are available like GPT-4 services are available. Different agents services are also available. So long chain, autogen, like agent services can also be are also available there. Computer vision services to analyze images, identify objects in the images, speech, convert audio into text. Okay, like creating a transcript in Teams Meet or converting speech into text. Okay, or text into speech. So in case if you submit a text to it, okay, it will use somebody's voice and will speak it out. Okay, so those services are available here. Natural language processing services like uh, reading the text, okay, and identifying the sentiment in that text in case if the text is a feedback, identifying sentiment in the text. So multiple such services are available on Azure. Okay, and those services can also be invoked here in Synapse Analytics. We can consume these services into Synapse Analytics. Okay, and for that purpose, the steps are given here. Just a minute, where I opened it. Here. Steps are given here. These are steps you can follow and you can do sentiment analysis here. Okay, so sentiment analysis features are also available in Synapse. Okay, you can do prediction, model prediction here. Sentiment, so these steps you can follow. You can connect to Azure AI services like text analysis and those services you can consume here. So consuming AI services possible. Okay, see, anomaly detection is possible, text analysis is possible, computer vision services are also possible in Synapse. Okay, these steps only, similar steps you will have to apply here also. Okay, translation services are available. Okay, Synapse ML services are available. So all these services are available in Synapse also. Okay, and even GenAI services are also available here. Now here what has happened is that Azure has given you something called as a Azure AI Foundry, Azure AI Foundry services. So all these AI services are available through Azure AI Foundry also. And here in Synapse, you can access all AI services through Azure AI Foundry also. So that API also works. So that kind of support is also available. They are enriching Synapse Analytics further. They are aligning the Synapse Analytics to the current market trends, and Synapse Analytics is also being aligned for generative AI here. Okay, and soon you will see Copilot appearing in Synapse Analytics. Okay, all different catalogs. Generative AI models can also be, their catalogs are available in Synapse Analytics. Okay, many such things you will see being made available in Synapse Analytics in coming days. So they are definitely hampering on Synapse Analytics as a tool. Okay, and in coming days, you will see Synapse Analytics getting aligned with all your current services. Synapse Analytics, it's not a new service actually. It's a quite old service. I started imparting the trainings on Synapse Analytics since 4 or 5 years. Okay, so it got introduced 4 or 5 years ago. At the top of this Synapse Analytics, then they created Fabric. They created Fabric, Microsoft Fabric. So Microsoft Fabric internally is using many Synapse Analytics services. So Microsoft Fabric, is further unified. It uses Synapse Analytics, it uses Azure ML, it uses Azure Databricks, it uses HD Insight. So Fabric is actually amalgamation of many such services together. Uh, yes, I will say unification of many such services is Fabric. Unification of many such services is Fabric. Now see a scenario that you have one application, Hadoop application, which has already been designed in SD Insight. SD Insight is a Hadoop platform. Some another application is in Databricks. Some another models you already have created in ML service, and you have to use all of them in one application. Okay, there then you will have to use the Fabric. Otherwise, it's difficult. Okay, to use SD Insight services within Databricks or Databricks within SD Insight. It is difficult. Okay, but that unification you can see happening in Microsoft Fabric. Okay, I think we have last 10 minutes remaining. Okay, questions, please. Thereafter, we will. In the top companies like data analysts are using Synapse to do data analysis. Yes, yes, yes. As on today, what is happening is no company coins upon a single tool. Remember. So companies are using analytics, data analysis, Synapse Analytics. They are also using Databricks. So there some of the projects are on Databricks and some of the projects are on Synapse. And now they need to pull or to integrate Synapse Analytics to Databricks, and that is also possible. Such integrations are possible. Vice versa is also possible that in Databricks, if you want to pull data warehouse data from Synapse, that is also possible. So inter-integration among these services is possible, and it is the need of the hour. So many companies are using. Actually, Suresh Goswami, you are asking about Synapse, but my Azure credits are over. What should I do? Suresh, in case if you can get Azure credits from your company, okay, in case if you want to learn it for your company, obviously your company will have to provide you hours. Okay, that is one thing possible. Another way possible is, this is not recommended way, okay, to create get free subscription. Another free subscription. That way also you can try. Okay, get another free subscription, and there also you can practice. But one thing you will have to be very particular about, that you have to keep closing your services. Okay, remember, Synapse Analytics services are costly. So whenever you are getting free subscription of 12,000 Indian rupees, okay, and if you keep your dedicated server running, over the night it will consume all your credits. So you have to be extremely careful, okay, to uh, judiciously use these services. Acha, Shubham, I am aspiring data analyst, and if the data is big and Python will not be able to handle it, then why should I even learn Python? Should I not learn big data tools like Synapse? You are absolutely right, Shubham. But you still need to learn Python, because in Synapse, whenever you want to do critical customization, you will have to use the Spark, and thereby you will have to use the Python. So you will have to use a Python there. In Fabric also, okay, you can do development, but wherever you have to do customization, there also you will have to use Python. So as of today, I consider for myself at least that Python is unavoidable. Foundation is Python. Yes, Python is unavoidable. In case if you haven't learned Python, I will say you please learn Python. Once you learn Python, many horizons are open for you. Many opportunities are open for you, because every tool as on today, support Python in one or another way. So in case if you learn Python, you will increase your versatility. Okay, you will be in position to work with many such tools. I have heard about Azure passes, which provide credits of 100 USD, where I can get such Azure free passes. Azure has stopped the process of awarding the passes. Let me clearly mention that thing. I haven't seen such passes being awarded in recent time. They have stopped that process. Or those are not free passes. Those passes are to be purchased. In order to get the free access, what you can do is you can get free Azure subscription. For that purpose, you will have to use your another email ID. That is again not recommended from me to suggest you. But just a hint I would like to give you. You will create another email ID, and through that you will use it. Get the free subscription, and thereafter you can practice more and more. Okay, we do offer our training courses for this, and there we offer you credits. So credit is a part of those courses. Okay, those credits are inclusive, including the Azure subscription. So we do offer such courses. Okay, you can keep a watch on our different offerings, and you can register yourself. Okay, such courses offer you less fees also. Okay, and within less fees, we uh, offer weekend courses also, Saturday, Sunday only. So in case if it is a 5 days course, okay, every Saturday, Sunday, consecutive Saturday, Sundays, you can attend that course. So we have lots of offerings. Okay, Shubha already, took you through a couple of slides showing you our offerings. You can refer to that. You can connect to Shubha for that. Okay, he will give you more idea about. Before you leave the terminal, humble request is to fill the feedback. Okay, and feedback is extremely important for us. So please help us in that way by submitting the feedback. Learning these cloud technologies like Azure, AWS, etc., how much important it is for data analyst? Extremely important. Extremely important. Yes, Manoj is asking for list of courses. So Shubha, this is for you. Please interact with him and provide him our offerings. So let me tell you why it is important. All the organizations, okay, are preferring the cloud because it is much cheaper. Okay, there are organizations in order to meet the compliances, company compliances or country compliances, may want to keep their data with the premises. There only perhaps they will not use cloud. But yes, there also cloud has a solution that your data will be on premise, but processing, okay, happens in your premise, but from Azure services. Okay, so that kind of thing is also possible. Please provide me the list of the Python courses as well. Yes, Subha, these things are for you. Okay, please interact with them and provide them the necessary information. So, what is happening as on today that cloud is becoming indispensable part of project uh, development and implementation. Indispensable part. Read more. There is more. Acha. Okay, let me just scroll up. Huh. Because sometimes I hear companies do not trust cloud companies to do security issues. So, should we even upskill ourselves in cloud technology or not? And next question is that is not very difficult to learn all the cloud technology, which I should learn AWS, Azure, or what? Asha, Shubham, I have 2 points to make here. Yes, many companies do have compliance that they do not allow their data to go out of the company premises. Okay, so what cloud is offering for them is your data will be processed in premise. It will not leave the boundary of your company, but billing will happen on the cloud, and cloud being a cheaper. Okay, it is affordable. You do not have you have to have your cluster on premise, but billing you will utilize your cloud services. Okay, so that is one approach. So for such companies who do not want to use a cloud for the security reason, for them the point is they can use this feature. Now, as of now, I am not able to recall this feature, name of this feature, but yes, there is a feature that data is maintained within the premises. All whatever your custom services and proprietary custom security and proprietary security still is applicable there. Only billing will happen on the cloud, okay, with a cloud cost, okay, cheaper cost. That is one thing. Second important point, what you asked is If it is not very difficult, which cloud technology to use? AWS, Azure, and what? Now, here what I would like to mention is that different clouds. There are mainly three clouds as on today. Google Cloud is there, AWS Cloud is there, Azure Cloud is there. For all these clouds, concepts are same. So, if you understand one cloud, okay, switching over to another cloud is very simple. That is one thing. Second thing is, I will always recommend you not to stick to single cloud because let me tell you, every company, almost every company, using multiple clouds. One project on AWS, another project on Google. So every company uses multiple clouds. That's why limiting yourself to a single cloud is not again recommended. Okay, but and once you learn one cloud, using another cloud is not big challenge. Enjoying learning. Could you share your LinkedIn, sir? I wanna connect with you. Shubham, thanks for your inquiries, but I am not supposed to share my details. My LinkedIn profile is there, but it is with a Shubha. Okay, you can interact with a Shubha, and you can get more details about me. Okay, even I listen now that they are using multiple clouds. Very correct, sir. Thanks. Yes, yes. Everyone, please do give the feedback. I think that's all from me. I too have enjoyed this session. It is a time for us to conclude the session now. So thanks everybody. Okay, so before you do, please fill up the feedback. Okay, and over to Shubha now. Shubha, over to you.
Thank you so much. Thank you so much, everyone, for attending this session. I hope everyone enjoyed. It's a humble request that everyone please do give your feedback on the given link and do redeem your learning achievement badges before you end the session. Once it's done, you can end the session, and a very happy weekend to everyone. Thank you so much once again. Thank you so much, Chandrasekhar sir, for this wonderful session. So that's it.
Thanks, Shubha, for your cooperation. And yes, wish you all best, okay, on this new technology. I will drop myself now. You continue, Shubha.
Yes, sir. Everyone, it's a humble request. You can uh, end this session once you're done with redeeming your badges and giving your feedback. It would really be appreciated. Thank you so much, everyone. Thank you so much once again.